Assalamualaikum and hi everyone. We are from BU 3A. We would like to present our mini project Fireproof Balloon. Our mini project based on the concept of convection. Heat can transfer by convection. Let's relook the gas particle in this room. They all roughly have the same energy because they are all moving about the same speed. When the particles by the fire, they gain energy from it and they start move faster because spread out. So that bit fluid become less dense and it start rises. When those particles rise, they cannot leave nothing behind. The cooler air or fluid move in to replace them. This cooler fluid is by the fire, so the particles gain energy and the fluids become less dense than the fluids above it. The fluid rises, pushing the other particles back and replace them. The problem statement: heat transfer in liquid and gases is through convection and water absorbs much more heat than air. And the main objective of this project is to investigate how heat is transferred through differing materials, in this case water and air. Objective of this project: first, to describe the relationship between water's heat capacity and thermal heating or cooling. And second, compare the thermal conductivity of air and water.
Okay, let's see what is the material that we use in our project. First, balloon. Second, candle. Third, water. Fourth, lighter. And last, we use the stopwatch. The cost of our project is only RM2.
Okay, I blow and pour water and without water. Okay, we take the balloon that have no water. Firstly, I will take lighter and light up it. Okay, I will take the stopwatch and start it and show you the time the balloon pop. Okay, I will start it. Show it. These are the time that the balloon pop. Next, I will take the balloon with water and a stopwatch and I will take the time the balloon with water will pop. Okay, I will start it now and show you. This is the time taken the balloon with water pop.
On discussion, as the water-filled balloon is put on the flame, the heat of the flame is easily absorbed through the balloon and into the water. The water directly above the hot spot rises, cools and sinks again, carrying away the heat from the hot spot. This cycle is called a convection current. In other words, the thin rubber surface is being heated is called by the comparatively large volume of water above it. This cooling process continues until either all of the water in the balloon becomes too hot or until a far more concentrated source of heat, such as blowtorch, is applied to one small area on the balloon. When an air-filled balloon is placed in a flame, it bursts. Air is relatively poor conductor of heat away from the thin layer of rubber. As a result, the rubber overheats and the physical bonds holding the rubber polymers together are broken.
We can see the impact of our mini project through the application on our daily life. First, when we boiling the water, the temperature of molecules within those liquids increases and they slowly begin to move in a rapid rate. These molecules get charged up, thus producing kinetic energy. These hot water molecules residing near the heat source tend to become less dense. They rise above cooler dense molecules. As these hotter molecules rise, they tend to cool down and begin to sink, replacing cooler molecules. These movements occurring within this boiling water via the convection currents. So next, we can see at the car radiator. Car engines are cooled by convection currents in the water pipes. Water is a very good substance to carry the unwanted heat away from the engine to the radiator, and the radiator is a heat exchanger where the hot water gives up its energy to the air. When a car engine has been running for a long time, a lot of thermal energy or heat is produced. It is necessary to cool the engine so that it does not overheat. The engine is surrounded by a water jacket. When the water in the water jacket gets heated, it flows into copper tubes, which include many cooling fins. A fan causes air to flow past these tubes and cool the water in them. The cool water flows down back into the engine through a hose at the bottom. A water pump is normally employed to facilitate the flow of convection currents back into the jacket, these tubes, and cool the water in them. The cool water flows down back into the engine through a hose at the bottom. A water pump is normally employed to facilitate the flow of convection currents back into the jacket. Last, we can see at the phenomenon of sea breeze and land breeze. We can see the sea breeze. On a sunny day, the land heats up more quickly than the sea because land absorbs heat faster than water. Hence, air over the land surface becomes more heated than air above the sea. So, the hot air over the land being lighter move up and the cooler air from the sea take its place. Thus, a cool and comforting breeze blows from the sea to the land. Therefore, it is called sea breeze. For the land breeze, it occurs at the night, is opposite. The sun is not there to heat and the cooling process has started. The land gives up heat more quickly than water. Thus, the air above the sea remains warmer and moves up while its place is filled up by the cool breeze blowing from the land. Therefore, this breeze from land to sea is called the land breeze. Thank you for watching. Hope you enjoy with our video.